Today I would like to look at the last type of problem. These are projectiles launched off the edge of a cliff. This is the Big Daddy long ones. This is probably going to be the longest problem you will have ever seen up to now. Alrighty, so sample number one, I think there's only one, I could be wrong. A ball is hit at 53.1 degrees. Why would I pick 53.1 degrees, do you think?
Something to do with like coast or something like that.
Well, you'll find out, yes. Above the horizon and has an initial velocity of 10 meters per second, showing them we're off the top of a 400 meter high cliff. So very tall. You are asked to find VV, VH, time of rise, height of rise, time of flight, range, and velocity at impact. So let's see here. Let's find VV and VH. Oh, I thought I had these. All I had to do was click. No, I'm going to have to actually draw them. Oh, boy. Alrighty, so VV and VH. Well, VV is always equal to V sine theta. So in this case, that's going to be, is it 100? 10? 10 sine 53.1. And the reason that I pick 53.1 is because you get a nice, beautiful 8 meters per second. Right? Well, remember that you've got this triangle here, right? This is VH, and this is VV, and this is V, right? So opposite is sine over hypotenuse, right? So sine theta is equal to VV over the hypotenuse, which is V. VV is always going to be equal to V sine theta. And VH is always going to be equal to V cos theta. So in this case here, that's going to be 10 cos 53.1, which is 6 meters per second. So the only reason I picked 53.1 is so that I get nice digit, nice integer values for my horizontal and vertical, right?
Yeah. So now you find time of rise.
Okay, so the next thing to do is to find the what? Time of rise? Okay, so time of rise. How are we going to find the time of rise?
You use that 8 doing something, right?
What is it? D?
Well, we're going to have to use VV, you're right. VV was equal to 8?
Yeah.
Okay, now at the peak right there, what is the vertical component of velocity? Exactly, 0. So we're going to write VF equals VI plus AT. The final vertical velocity is 0. The initial vertical velocity is my 8. And my acceleration is minus 9.8 times time. And I get a time value of 0.816 seconds. Is that correct? What you got? Okay. All we're really dealing with here is, I mean, really, we're just talking about a ball thrown straight up at at initial velocity of 8, right? How long does it take before it gets to 0? Right? Because the horizontal and vertical components are completely independent. They have no relationship with each other. So the height of rise, again, we're going to talk about this distance here, right? So I could probably use D equals VIT plus a half AT squared. I could probably go VF squared equals VI squared plus 2AD. I could use either one of those, I think, right?
Or you can just do the one that you showed us in the short one. D equals half of T squared.
I guess. Well, no, could I? I can't because the VI is not 0 here.
Oh, crap, yes.
Right? So I can't. So which one of those do you feel more comfortable with? Do you feel comfortable using this T that we calculated? Or VF is 0, VI is 8, 2 minus 9.8, solve for D?
Yeah, let's do
I feel more comfortable with this one, right?
Seems safer.
I agree. So 0 squared is equal
Would it be the
to,
same thing?
it should be. We can check it out. No? Okay.
There's a negative 9.8?
Yeah. So this is going to be
64 minus 19.6.
64 divide by, isn't it? Didn't you say minus 9?
64 subtract.
No, because it's the 8 squared goes over, and then to get rid of the 2 times minus 9.8 times d, you have to divide.
Still doing some stuff. Good. Not minus that thing.
Okay.
But it should be 3.26.
3.27 meters, is that what you got? Sean's wondering if this would have given us the same thing.
Yeah.
Should be 3.27. Height of rise. Okay, total time of flight. Now, in this case, is the time up equal to the time down?
No.
No.
It goes up.
Because, exactly. The time down is a considerably bit more, right? So the way I like to do this, because it's just beautiful.
Actually,
It's kind of an elegant solution, I think. What's the height of this cliff? 400?
400.
400 plus 3.27.
Right. Okay. You could do that too. Yep. There's two ways. Let me show you the elegant way, and then I'll show you the other way, the cheater way. Okay. So I'm going to write d equals VIT plus 1/2 AT squared. The displacement is minus 400. The initial vertical velocity, I think, is 8, right?
Yeah.
T plus 1/2 of minus 9.8 T squared.
It's going to be a damn drag.
You bet. Can I take the minus 400 to the other side? Just put 0 there. Is that okay? So I'm going to have minus 4.9 T squared.
But you can't do that. You got to make that positive.
Why?
You can't make the square negative.
Why not?
We're doing quadratics.
Why not?
I don't know. I just thought that was cool.
Well, that's okay. All right. So can I just do this?
You can, no, you can't do that.
Why not?
It has to be a positive 400. Right?
Yeah.
Yeah. Thanks, Sean.
All right. So what you want me to do, Mike, is take the 1/2 minus 9.8, which is minus 4.9, and take it to the left.
Yeah. But,
Okay? And you want me to take that, oh yeah, not minus, positive on the left-hand side, right?
yeah, and then make negative 8.
Okay. 8, so this is going to be?
Keep it 400.
Isn't that what I just had before?
No, you moved the 400 and kept it negative.
Yeah, you just the right.
No, I moved it over, and then I changed the sign and everything.
It's just weird, right? It's good now.
Oh, it's good? You feel happy?
It's good now.
I know. I like my t-squareds being positive too. Okay. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Is there anyone that's unfamiliar with the quadratic formula?
No.
Unfamiliar with it, Austin? Okay. I'll have to come by and talk to you about that. The quadratic formula is what you use to solve when you've got like a t. Oh, there should be a t there. Right? Okay, so it's going to be minus b, so minus a minus 8 is 8, plus or minus square root, b squared is 8 squared, minus 4, a is 4.9, c is negative 400, and it's all over 2 times 4.9. Guess I didn't delete it last time.
4.
Okay.
Plus
8 plus or minus square root
64 plus 7840.
64 what?
64 plus 7840.
all over 9.8, right?
Yeah.
Okay.
Square root of second times 4.
Which is, can I skip a step there?
Should the answer done. It equals the answer.
88.9.
Okay, now, it's plus or minus 88.9, but I'm over a positive 9.8. My time has to be positive, does it not? You can't have negative time. My time has to be positive. So should I do the 8 plus 88.9 or should I do the 8 minus 88.9? It's the 8 plus 1. The minus 1, I'll show you what that means in a minute. So it's going to be, you end up working out with, I think
Does
it's,
that do anything? Making subtract?
I'll show you right away what it does. I think you get, am I right when I say 20.3 seconds? I don't have a calculator here and I'm kind of converting stuff in my head with my notes.
It's 9.88.
Yeah, I got it 9.88.
Can we say 9.9 seconds?
Sure.
Okay. Yes, there's a change from this question on my notes, so that's like that. Okay, so that's kind of the elegant way of doing it, right? And if you're familiar with the quadratic formula, it's not too bad. It's a bit long, but it's kind of, I don't know, it makes me feel smart that I can do that. What's another way that you could do it?
Alex, let's say something.
Yes, Alex was going to say something. Well, you were talking about how else you could do it.
You're like, oh, you just add it to it.
Well, yeah, all you do is
this.
take the time up, and then it starts with the initial velocity of 0.
Yeah.
So that is half of, or d is equal to half of gt squared.
Okay, so what he's saying is go d equals vit plus a half at squared. Your d is now minus 403.27,
3.27.
exactly, right? So it's minus 403, oops, 0.27. The initial velocity, we're talking about just the fall, so that's 0 minus 1 half minus 9.8 t squared, right?
I would not remember the other.
Oh, no?
You don't have to use that formula.
There's no quadratic formula there, though, right? So it's really just minus 4.9 t squared, right?
It's just
So t equals the square root of minus 403.27 all over minus 4.9. What do you get, Alex? How come you don't get the same value?
because that's only on the way down.
Exactly, that's only the time on the way down. So you have to add 0.816, which was the time up, and you get 886, right? 9.886 seconds, which is, for all intents and purposes, exactly the same as that. So I really don't care, Jimmy crack corn, which way you do it.
Smokes crack?
No, Jimmy cracks corn. I don't even know what that means, but I don't care.
Not cracks.
Exactly. Fair enough. What's the range? How far from the base of the cliff does it land, right? So now we're going to use that horizontal velocity that we had way back when of 6 meters per second. The total time is my 9.9, so it's simply v equals d over t.
Wait, what's the 6?
6 is the horizontal velocity, right? So you're going to get basically what? Almost 60 meters, right? Is that what it is? Okay. 59.4 meters. Last bit. The last question is always, what's the velocity of impact? Okay. VH, VV, final velocity. Now before, our final velocity of impact was exactly the same as what it was at launch, but that's when we were on a flat surface, it's going to be different here, isn't it? Do we know the VH? Yeah, it's still 6. Do we know the VV?
Yeah.
No, it's different.
No, it's different. It's going quite a bit faster, right? So I would suggest VF equals VI plus AT, and you could do it a couple ways here. Because you know the total time is 9.9, you could use 9.9 and the vertical component of 8, or you can use 9.07 with a vertical component of 0.
What exactly are we finding though?
We're trying to find the overall velocity impact, the combined horizontal and vertical together. Before I can do that, I need my vertical. So I'm going to go with the initial one, which was 8 plus minus 9.8, and my total time was 9.9. Someone's going to have to help me here.
What is that, VI plus AT or is it?
VI plus AT, yeah. VF equals VI plus AT. That's kinematics equation number 1. Someone with a calculator help me out here.
Negative 89.02. Is that right?
I don't know. Sounds about right. That's going to be about 100. Yeah, that's about right. So in other words, it's going a whole lot faster down than it is going sideways. Right? Someone's going to have to work that out for me. All right, when you find the angle, it's second function tan, 89.02 divided by 6.
86 degrees.
That sounds about right. 86 degrees, and how do we call that? What's below the horizon? BTH. Sounds like a sandwich. Here's a second sample. This one isn't really the off-the-cliff kind, but very similar. Stuntman attempts to jump 40 buses using a 40-degree ramp. Right? Each bus is 3 meters wide. His speed is 130 kilometers per hour. Will he make it?
He's really fast at running.
He's on a motorbike.
Didn't say that.
Oh, you're going to jump 120 meters. Flat. Hop around.
You guys want to try this one on your own? Give it a whirl. Give it a try. Okay, so what would be the steps here? Alex asked a really good question. Are we assuming that the height of the landing ramp is the same as the launch ramp? And you pretty much have to, right?
Well, maybe the bus will get taller.
Or it's on or if it was on a hill or something, right?
Or it was in space.
First step is to take that 130 and divide by 3.6 to get how many meters per second?
36.1.
Okay, and then you got to find your, looks like I got the whole thing down here.
What is that for?
This is the answer. I just didn't delete it from the last time I taught class. Right? So what's your horizontal component is going to be 36.1 times cosine
27.6.
40,
What?
which is what?
27.6.
Okay. VV is going to be 36.1 times the sine of 40, 23.2. Now, all you really have to do here is find you got to find the total time, right? How'd you find the total time? Okay, so did you go VF equals VI plus AT, plug 0 in there, use that vertical component of 23.2 minus 9.8 T, and what'd you get for a time? That'd be around 2.37 seconds. Multiply that by 2 because there's up and down. That's going to be 4.74, right? And then V bar is equal to D over T. The horizontal is 27.6. The time is 4.74. 4 times that is well over 100, isn't it?
All cube, yeah.
What is that going to be?
130.8.
130.8. And then I guess it's just a matter of figuring out 40 times 3, right? Is 120 meters. So he's got like 10 meters to spare, right? In fact, he's probably got to make sure that his ramp, like 10 meters to spare is quite a bit, right?
Yeah.
He probably wants to do what?
30-meter ramp.
Yeah, he probably wants to make sure that he lands somewhere in the middle of the ramp, right? Give himself some buffer here and buffer there. Do you think stuntmen actually do calculations like this?
There's some people who do it now.
Probably, yeah.
Back when he was like, no, just throw me in there.
Just pin it, right?
Crank it up a little bit.
Put me in that wrong ship.
Yeah. All I need is a guy in a pair of cutoff jeans at the bottom in a rowboat for safety. That's all I need.
Throw me in.